presentations that we have tonight are Ryan Keeling, Wade Rose, Robin Danowitz, Julia Forbes, Marie Watson, and Robert Brown. We're going to begin with Ryan, who will be presenting to us about the management plan for the historical landscapes with GIS. And this is going to be talking about something very, very locally here. And we're delighted that Karen Marzoni from the Henry Ford Estate is here, and John Berger, who's a veteran at the estate as well, is here to join us and knows a great deal about that. So here's where we will begin. And Ryan, you're on.
Thank you everyone for attending this evening. I would like to present my project here, and I'd like to start with a quote that I think is very appropriate to introducing my topic. So this is from Walden by Henry David Thoreau, The Pond in Winter. As it was desirous to recover the long-lost bottom of Walden Pond, I surveyed it carefully before the ice broke up, early in '46, with compass and chain and sounding line. There have been many stories told about the bottom, or rather no bottom of this pond, which certainly had no foundation for themselves. It is remarkable how long men will believe in the bottomless of a pond without taking the trouble to sound it. So, my name is Ryan Keeling. I'm a neural science student at the university, and my project is entitled, like Dr. Keys said, Augmenting Management Plans for Historical Landscapes with GIS, a case study for Henry Ford's Keeling. And I worked with Dr. Dick Nebrowski on this project, and he wanted to be here, but his classes he was at 6. So here's an outline of my presentation. I'll give a brief introduction and some important terminology that will be important to understanding my project, study area, the methods that I applied to this project, some results, and I'll conclude. So here's our campus. I'm sure you've seen a picture like this before. So we're sitting here, and this is what I took a look at. This is our lake on campus. We refer to it as Spear Lake. It's about 6 acres. So the Henry Ford Estate is a big part of our campus's history. So the estate began construction around 1914. It was designed by the Fords, largely by Jens Jensen. The intent to develop in a rich environment for birds, native plant species, and other organisms. So 1,300 acres of farmland was converted into this estate, and it also included the lake. Over the last 100 years, little research has really been done on Keeling Lake and its morphometry, its shape, as well as its bathymetry, the underwater relief. And this project is hopefully been used to gain essential morphometry data on Keeling Lake and share and collection maps. So here's some important terminology to understanding my project. So GIS, that's what every other word you hear out of my mouth, GIS. So it's a means of gathering, storing, analyzing, sharing, and presenting spatial data. So as you can see in this picture, all of these pieces of data lie in the same plane. They all have the same geographic footprint, all related. So to georeference, another term, it's providing spatial information to a raster, which is like a picture. So an example of this would be historic aerial photographs. You'll see a lot of those later. Ground control points, these are features that can be identified on the ground, similar and are similar between time periods. And lastly, bathymetry is underwater relief. So my first challenge was to organize the available spatial data. There's lots of data that's been collected over many decades, thanks to Dr. G and others. So there's historical landscape plans from Jensen. There's aerial photographs. There's written verbal accounts and other projects I'm working on. The EIC has a very ambitious management plan as well. So this was like the defining moment of this is what I'm going to do. I found this document, and this is the 1914 plan of Jens Jensen, that's his signature right here, outlining how the lake was to be dug. And if you went out there today and looked at the lake, you wouldn't really think of it as a man-made lake, but in fact it is. Here's another plan. This is 1920, showing like his grand vision of everything together. The lake still has the same shape as we saw before. So there's lots of things that I had to do to understand what these documents mean. I was thankful that Karen Marzoni didn't think I was too crazy when I went looking for these documents, but she thankfully let me get a copy of it at first. So I've been working on a document like this, trying to get as many clues from it as possible. Karen and I also went to the Benson Ford Research Center where all these are kept, and this is me there. And these come out in these big canvas folders, and you pull them out, and you cross your fingers and hope that they don't crack. Some of the paper documents that the state has, or we scan them in our large document scanner to create digital copies as well. So now that some of that data has been organized, it was time to start to georeference or provide spatial information to these documents. The historical aerial photographs and the documents kind of go hand in hand, some go before. And yeah, many of the aerials from EIC, Justin Sarin, Dr. W's, and georeferencing these photos allowed for easy comparison between many time periods. So this was very challenging with the landscape plans because the ground control plans were just missing. So this is 1937, and you can see the fence lines that I have here. You can see the tree lines pretty easily, and I was able to use that to bring in the plan. Which took me a lot longer than I'd like to do this. So going through the time period now, so starting in 1914 when this document was first drafted. I'm going to go kind of fast here to go through the time period. So just watch the shape of the lake and how it's changed, especially this part over here and right here. We'll see how they go. Look at canvas too. 61, this is finally figured it out, thank goodness. So this is what I've been told is the basement of the science building's fill right here. So going back, you can see you can see how the orchard's changed as well. So this is a little closer to what we recognize it as. And that's what it looks like today. So the lake has obviously changed a lot over the last 100 years, but is this because this was not in fact a as-built document? That's still up for debate, and I'm still trying to bring some more clues to figure that out. But looking at the footprints of today, which is in red, and then 1914, which is in blue, you can see that the shape is quite a bit different. This, of course, was built in, probably where campus was built in 59. I'm not sure if this was just never dredged or filled in. So to compare the document and the imagery that the document outlined, I also went to the field and collected morphometry data. So going out in the field, I took 300 points around the lake. I went out in my kayak with a GPS unit and a portable depth sounder to get my X component, my Y component, and my Z component. This is a 3D bathymetric model of the 1914 lake. So pretty regular shape, but it was just over 1,700 feet long, and the maximum depth right here, 13 feet. here's the same thing in 2014 with my field measurements. So the depth is quite a bit different, 7.7 feet. Maybe around here. And it's obviously fine in length as well. So here's some of the stats. I think the most impressive, obviously, the depth as well as the mean depth declined quite a bit, and a large change in volume as well. Here's some more stats. So what does all this mean exactly? Again, is this an as-built document? Is this important to note that the imagery has changed so much, the shape has changed so much? So this picture is from April 6th, and right after the lake froze, there was a large fish kill, which mostly was goldfish, but nevertheless, there is no more deep water protection for fish in this very deep area. So it's quite a bit different shape. And then to conclude, these methods that I applied are an efficient way of bringing together this data to help to assist a management plan for the lake. Is it a good idea to spend a lot of money to dredge the lake and try to get it to the same shape as it was in 1914? I'm not sure, but in my opinion, I think it's better just to let it go and let it be in the ecosystem. And I'd like to acknowledge Dr. Navaralski, who assisted me throughout. Like I said, he's teaching the class right now with Cameron Zoni, very, very helpful for getting these plans to me and assisting me along the way. Dr. Douglas for the knowledge of the state. Justin Sarin for bringing all this data and how I should deliver it. Rick Semick, of course, from EIC, Mike Karen, and any questions? How much time?
Go ahead, take your question.
Could you go back to your updated plans?
Yes.
Is there any reason that the shape or the lake was originally shaped in such a way, or was it just kind of like, oh, this is pretty, let's make it like this?
That is a good question. I think it has to do with continuing with the Great Meadow, the Jensen's Meadow,
Oh, okay.
the long meadow. So going back, sorry, I can go back here. But
There we go.
so this is Jensen's Meadow here, looking down, it makes you, Jensen designed it so it makes you get out and see the rest of the building. Yes.
Why was the end filled in? You said that was maybe the basement of the science building or something?
That's a good question. Well,
There's no building there, so.
no, so the fill from the basement. They didn't want to.
Oh,
They
so
didn't have a
they
place
dug
for it,
out
so
the
they
basement
thought.
and dumped it there.
They thought it was. Yes.
When you took the depth data, how did you measure that? Did you wait for the device to hit the bottom, or did it?
So this is a pretty cool device. So it's basically just like a flashlight. You put it in the water, and it gives you a visual readout of the depth.
So the sediment depth at the deepest point, or the other point might be deeper than the actual lake.
Right.
Possible.
So I chose because there was that problem. There was a lot of sediment at the bottom. Mostly got stuck a few times. But I chose to go at the top of the sediment with this device. Yes.
I'm dying to ask this question. What do you think may have caused the lake to fill in?
So obviously filling in from the campus didn't help, but also the buildup of sediment from organic matter. I really think that it was never dug to the original plans for Jensen, because that is quite a bit of change. But I mean, 100 years of change, it's quite a bit of, 100 years is quite a bit of change.
sunfish for many, many years, and then somebody put goldfish in it. And they took it over, that took it over because it disturbed the nests that the fish made. And then about 15, maybe 20 years ago, one student for his field biology project put bass and pike into the lake, little minnows. And they grew to big fish at about maybe a foot long or more, feeding on the goldfish. And then the spring came, and what happened on April 6th this year also happened on the previous year, and the fish were found up on the shore. They died in the lack of oxygen in the lake. So, but the goldfish population decreased, but then shortly after it increased right after that because there were no predators. Okay, thank you very much, Ryan.